Hello everyone, we'll start question number 10. A guy wire attached to a vertical pole of height 18 meter is 24 meter long. Okay, now let's see. This may be the ground, fine. And here we have one vertical pole. There is a pole standing at right angle, fine. So this is the pole. On this pole, what happened? A guy wires attached. Here what happened? A wire is attached. And what happened now it falls like this. Just example once, I'm just giving you. Okay, and here what happened? This is what we call stack. Here on the wire at the other end, what happened? I think there is something like this. This is what? Stack. We have seen on the roadside all these things. Okay, now the question is saying, has a stack attached to the other end? Yes, I have shown it now. How far from the base of the pole? Here base of the pole means this is called the base of the pole. This is what? Base of the pole. If we want to make this wire straight, taut, what happened? It has to go this side, so that now it becomes what? Straight. So the question is saying that, let's see, how far from the base of the pole should the stack be driven so that the wire will be taut? That means we have to find the distance between this and this distance we have to find. First, let me draw the figure. This is the ground, this is the electric pole, and this is the guy wire. Okay, here I'll give A, here I'll give B, and here I'll give C. Now it's vertical pole, so here the angle is 90 degree. Here I'll write 24 meter. So let me just show here once, 24 meter. And what is the height of the pole? 18 meter. 18 meter. This BC, we have to find it. Okay, first let me write, let AB be the height of the pole. Height of the pole. And AC be the length of the wire. And last one, let me write, let BC be the distance of the stack from the base of the pole, from the base of the pole. Okay, here let's see. Here I'll write here, what is AB? AB is 18 meter, and AC is how much? 24 meter. And this BC, we have to find it. BC is what? This is what we have to find. Okay, so the triangle that we see here is a right angle triangle. So what happened? We can apply Pythagoras theorem. So I'll continue using Pythagoras theorem. In triangle ABC, what we get, I can write here, AB square plus BC square equal to what? AC square. Here AB is 18, so 18 square plus BC square is what? Here we have AC is 24, so 24 square. Okay, let's see now. 18 square, how much? We have 324 plus BC square is what? 24 square, we have 576. So what happened now? BC square equal to 576 minus 324 implies BC equal to, here how much we'll have? 576 minus 324. We have 2, we have 5, and then we have here 2. Okay, so 252. 252. 2126. 26, then 3. The next 3, 2, 1. and then again 3, 7. So what happened? 2 2 times, 3 2 times, and 7 just one time. So we'll write here 2 square into 3 square into, next we have 7. So 2 and 3 will go out of the root and 7 remains inside. So now how much we have now? We have 6 root over 7. Here we have to write in terms of meter only. Let's give the conclusion. Therefore, the stake should be driven at a distance of 6 root over 7 meter from the base of the pole. Now we have question number 11. An aeroplane leaves in the airport and flies due north at a speed of 1000 km per hour. At the same time, another aeroplane leaves the same airport and flies due west at a speed of 1200 km per hour. How far apart will be the two planes after 1.5 hours? We have the airport here. Okay, now what happened? The first thing that you should know is this is the north, this is south, this is east, and this is west. What happened now? The question is talking about two aeroplanes. One flies towards north direction. One flies to this north, and what happened? Another flies to the west. Okay, so in this direction, one moved to the north, one moved to the west. After 1.5 hours, what will be the distance between this aeroplane and this aeroplane? That means we have to find this distance. But the speed of the first aeroplane that moved towards the north is 1000 km per hour. And what about the aeroplane leaving towards west? And this is 1200 km per hour. Now after 1.5 hours, we have to find the distance between these two aeroplanes. First, I'll draw the figure. Here we have the airport. Okay, so I'll give here A, I'll give here B, and I'll give here C. Here this is north direction, so let me just write here north, and this is west. And what is the speed? The speed for the aeroplane that flies due north is 1000 km per hour. 1000 km per hour. And what about the west? This is 1200 km per hour. Okay, we'll start the solution now. Solution. First, let's find the distance. First, let us find AB. What is AB? I'll just write here. AB is nothing but distance traveled by the aeroplane in the north direction. In 1.5 hour. 1.5 hour is what? We have the formula that distance is given by speed into time. So what is the speed? Speed is 1000 km per hour. Kilometer per hour. And what is the time? The time is 1.5 hour. Okay, so we have now 1000 into 3 by 2. Now it becomes kilometer. So that if we cancel 2 and this 1000, we are sure to get here 500. So 500 into 3, we have 1500 kilometer. Below this, I'll find BC. What is BC? BC is nothing but distance. All right, traveled by the aeroplane in the west direction, in the west direction, in 1.5 hours. This is also same only, 1200 kilometer per hour into, here we have 1.5 hours. Okay, so what happened now? Equal to 1200 into 3 by 2. So if we cancel here, we'll get 600. 600 into 3, we have 1800. Then it becomes kilometer. Okay, now in this triangle, what happened? We know the length of AB and we know the length of BC. Now we can find AC. Don't forget, this is to be taken as right angle only, using Pythagoras theorem. In what is that? In triangle ABC, in right triangle ABC, we have AC square equal to what? AB square plus BC square. So here AB is 1500 square plus we have 1800, then again square. Okay, so 15 square is, we have 225. So let me write here 225. How many zeros? 4 zeros. 1 2 3 4. And 18 square, we have 324. So 3 2 4. And how many zeros? 1 2 3 4. Okay, so if we add this, how much we'll get? We'll get here 1 2 3 4. 4 zeros. And then 5 plus 4, it's 9. 2 plus 2, it's 4. Then 3 plus 2 is 5. Now we have to factorize this. Okay, so just pay attention here. 5 4 9, we have 4 zeros. This is what? This is nothing but 549 into, we have 10,000 like this. So 10,000 means easily we can write 100 square. But what about 549? Let's see now. Here 549. First I'll go with 3. 3 1 is 3, 3 8 24, and 3 3 9. And again let me go with 3, 3 6 18, then 3 1 is 3. 61 is a prime number. So what happened now? We have 3 square into 61. So this 549 you can write here 3 square, then into, we have 61, then into this. Okay, so what happened now? Therefore AC equal to root over 549, then we have 4 zeros. So here how can we write? We can write here 3 square into, what is the next? We have 61. Fine, 61, then again 100 square. So 3 will go out of the root and even 100 will go out of the root, but 61 remains inside the root over. So how much we have now? We have 300 root over 61, and this will be definitely kilometer. So the required distance between the two aeroplanes is how much? 300 root over 61 kilometer. So let's give the conclusion here. Therefore the required distance between the two aeroplanes after 1.5 hours is how much? Is, or you can say equal to, it's fine, is 300 root over 61 kilometer. We have question number 13. D and E are points on the sides CA and CB respectively of a triangle ABC right angled at C. Here what we know is triangle ABC is a right angle triangle, and here right angled at C means angle C is 90 degree. And again, the most important part, D and E are the points on the sides CA and CB. That means D lies on the side CA and E lies on the side CB. Now let's draw the diagram. Here we have a right angle triangle, and let's give the name here. I'll give here C first. C is the 90 degree, so don't forget this is right angle. And you can give here A, and you can give here B. D lies on CA, so let me just use the red color now. This is D, and I'll take here as E. Okay, but we have to prove that AE square plus BD square equal to what? AB square plus DE square. So how do we get AE? Only when I join AE. So now let's join AE. Next we have to join BD. Next DE. Given. First I'll write in triangle ABC, angle C is 90 degree. Next we need to write D and E are the points on the sides CA and CB respectively. Next, to prove, we need to write here AE square plus BD square equal to AB square plus DE square. Next I'll write procedure. Okay, first I'll take triangle AEC, right angle triangle AEC. So let me say using Pythagoras theorem. From which triangle? Triangle AEC. What we can write? I can write here AE square equal to what? We have AC square plus EC square. And let's write here from which triangle? From right angle triangle AEC. Next we'll take triangle BCD. First I'll write here, let me say from right angle triangle BCD. Okay, so in this triangle BCD, what happened? If we apply Pythagoras theorem, we can write here BD square equal to, we have now BC square plus CD square. Next we'll consider triangle ABC. So here I can write AB square equal to what? You can say AC square plus BC square. Here we'll write from right angle triangle ABC. At the last we'll write DE square DE square equal to what? DE means we have to consider triangle DCE, or you can say DEC, it's fine. You can say here DC, or you can say CD. Okay, CD square plus EC square, EC square. And here we have to write from right angle triangle, what is that? DEC, DEC. And here I'll give equation number 1, 2, 3 and 4. Let's see. Here I'll give equation number 1. This is 1. This is 2. This is 3. And this is 4. Now we'll be adding equation number 1 and 2. So I'll write here on adding 1 and 2. 1 and 2 we get. So don't forget, when we add the equations, left hand side should be added, and the right hand side should be added. So from equation 1 and 2. Fine. AE square plus BD square will be equal to what? We have AC square plus EC square plus BC square plus CD square equal to, here what happened, I'll make AC square and BC square as a group, and next EC square and CD square as a group. We'll see now. AC square plus BC square plus next we have CD square and EC square. So you can write CD square plus EC square equal to, here we have AC square plus BC square. Look at equation number 3. In equation number 3, AB square equal to AC square plus BC square. Now in place of these AC square plus BC square, I can write AB square. What about CD square plus EC square? We can write DE square, and here we'll write from question number 3 and question number 4. So hence proof. So let me write, therefore AE square plus BD square is AB square plus DE square.